So, hello students, good evening everyone. So, can you guys do reply if my voice is audible? So, please do reply in a comment box if my voice is audible to you. Okay, so thank you so much, Ophelia. Okay, so fine. So in today's topic, so let me introduce myself first. So this is Dhanush, and I'm from Seventh Sense, and I work as an HR from past 3 years. So I know you will be undergoing this TCS training. So in this today's session, we will be discussing about syllogisms and directions. So as you all know, so in aptitude there are three parts. So one is quantitative, so we call it as a quant, and we have logical and we have verbal. So quant is all related to your English grammar. I mean, sorry, quant is all related to your English mathematics, pure mathematics. So we may call it as a basic mathematics, right? So this logical section will come under your decision making capacity, logical thinking, decision making. So this is called what logical reasoning section. And when we go for verbal, this verbal is all related to your English grammar, right? So let's begin the session. So let's see what is syllogism, and let's see what is direction sense problem, and let's try to solve more exercise problem related to these topics. So before wasting much time, so let's get it in the topic. Okay, and if you have any doubts in between, so you can comment your doubts in comment box, and please don't hesitate to comment. Okay, so this is syllogism. So, a syllogism is a kind of logical argument that applies deductive reasoning to arrive at a conclusion. So, based on two or more propositions that are asserted or assumed to be true. So, no need to remember all this definition. So, just remember. So, we need to find out true statements, or the syllogism is only based on our assumption. Let's say, for example, if I say all girls are boys and all boys are girls, so literally this sentence doesn't mean any sense, or this doesn't make any sense. But we can assume this as a true statement, right? So, this syllogism is all about your assumption, your assertion or your assumption, right? So we need to select, or we need to begin a true statement. So in the syllogism, they will be giving you a statements, and they will be giving you a conclusions, and they will be giving you a option. So just see the statements, and after that, so just check which conclusion is true. So based on the true conclusion, you can select your options, right? So steps. So make a Venn diagram, derive the conclusion, and it's simple. Since when we compare this quantitative with logical, so logical is much simple, and we can easily score in this logical section. Because when you go for it will be more of formulas, calculations, and all. So obviously, it takes some times. So in this logical, so we can, if we are thorough with the topic, if we are solve more problems with a topic, so we can easily solve all these types of questions. So just three steps. So make a Venn diagram, derive the conclusion, and it's very simple. And this is not a rocket science, right? You all know how to draw a Venn diagram, I guess. Maybe in your primary or maybe in your high school, you have gone through this Venn diagram. So it's called sets. You may heard about this sets. So it's about intersection, union. So we will be representing those in a circles. So we'll be representing those in a circles. So we are using same Venn diagram in the syllogism to represent our statements. So derive the conclusion. So you can check for the conclusion, and this is not a rocket science. Okay. So are you getting my point? So am I going too fast? Can anybody do reply if my voice is audible and you have understand what is syllogism? Okay. So no reply from anybody. So I guess it's all clear. So let's see all the possibility concepts. So we call this concepts as a statement. So from now, don't call this concept. So we can call it as a statements. So let's go with some concepts like sum A is B. So how can we represent this sum A is B? So we can recall those concepts of sets that we have gone through in our primary or maybe in your high schools. So let's represent this in Venn diagram. So sum A is B. So we'll be taking two circles. So we can name one circle as B and we can name the other circle as A. So sum A is B. In the sense, it's called union. Union in the sense like two circles which are interconnected. So let's say one circle which is A and the other circle which is B, and these two circles are connected, which says some part of the A will be some part of B. Clear? So these are the statements. Some A is B is a statement, and this diagram is a Venn diagram that represents the statements. And based on this diagram, we can derive a conclusions. So let's say what are the possible conclusion for this Venn diagram. So some A is B, some is B is our first conclusion, and some B is A is our second conclusion. So this is all vice versa. So if some part of A is some with, if some part of A is with the some part of B, so we can always say that some part of B is with some part of A, right? So hope this concept one is clear. So some A is B in the sense the two circles which are interconnected, and the conclusions may be like some A is B and some B is A. So only these two possible conclusions are there, so we can't derive any other conclusions, because for this Venn diagram, so we can only derive these two conclusions. Okay, so some A is B and some B is C. So some A is B and some B is C. Okay, so let's take this as A circle and this is B circles, and this A and B are connected because in statement we have some A is B and some B is C, in the sense some part of B will be with some part of C, right? So for the sum A is B and sum B is C, so we have three circles which are connected, right? So some part of A will be within some part of B and some part of B will be within some part of C, and there is no connection between A and C. So that's fine. So let's take the circle A and circle B. So let's try to derive conclusions. So as I already told you, so only two conclusions are possible. So some A is B and some B is C. So if we take between B circle and C circle, so yes, only two possibilities. Some B is C and some C is B. So and if we take two circles like A and C, so we can't derive any conclusions because these two circles are not connected. They may be connected through B, but there is no direct connection between A and C. So we can say that since there is no direct connection between A and C, we can't derive any conclusion. And remember one thing, we can also make a negative conclusion if there is a negative statement. So we'll be getting to this point in our next slides. So for as for now, so just remember this. So if there is no direct connection between 2 points or two circles, we can't derive any conclusions unless and until the statement is negative, right? So between A and B, some A is B and some B is A, and between B and C, so some B is C and some C is B. So between A and C, so since there is no direct connection between A and C, it's not possible to derive any conclusion between A and C. Okay, so all A is B, all A is B. So this all A is B. So we can represent this like, so one circle within the other circle. So all the A values will be within B, in the sense. So B will be a bigger circle and we represent this A circle within B. I hope it is clear. So A is a small circle and B is a big circle, and we represent this A within B. So what are the possible conclusion for this? Like obviously, so some part of A is B and some part of B is A. So some A is B and some B is A, and we can also add all A is B here, right? So we can, there are three conclusions. All A is B, some A is B, and some B is A. So it's defined like we can derive three conclusions. So all A is B and some A is B and some B is A, right? So when the statements are positive, the conclusion must be positive. So when the statements are negative, the conclusion will be negative. Okay. So all A is B and all B is C. So all A is B and all B is C. So all A is B and all B is C. So A will be within B and B will be within C. So A circle will be within B circle and B circle will be within C circle. Right? So what are the conclusion between A and B? So as we already saw our previous concept, so all A is B and some A is B and some B is A. So between B and C, the same, all B is C. So some B is C and some C is B. And between A and C, yeah, so A is directly connected with C. So all the parts of A, I mean, all the values of A will be within all the values of C. So we can derive conclusions here. So all A is C. So some A is C and some C is A. Right? So I hope it's clear. So if you have any queries in between or if you are stuck in any of the concept, so you can directly ping in a comment box. Okay, so let's move with the concept 5. So some A is B and all B is C. So some A is B and all B is C. So some A is B means one circle connected with the other circle, and all B is C means one circle will be within another circle. So A and B are the connected circles, and B will be within C. So what are the conclusions? So between A and B, so some A is B and some B is A. So between B and C, so all B is C and some B is C and some C is B. So between A and C, so some A is C and some C is A. Right? So let's move the sixth concept. So all A is B and some B is C. So all A is B and some B is C. So all the A values will be within B and some B is C. So this is what the Venn diagram we can draw for this statement. So let's go with the conclusions. So between A and B, all A is B and some A is B and some B is A. So between B and C, so some B is C and some C is B. And we can't derive conclusions for A and C since because there is no direct connection between both of these circles. Right? So this is concept 7. So all B is A and all C is A. So all B is A and all C is A. So all the B values will be within A circle and all the C values will also be within A circle. Clear? So the conclusions. Yes, so between A and B, between A and C, we can derive conclusions like all B is A, all C is A, some B is A, some C is A, so all A is B and some A is C, right? So between B and C, since there is no direct connection, though these two circles belongs to A, these two are connected with A, but not with each other. So B and C are not connected. So since because there is no direct connection, we can't derive any positive conclusions here, right? So we have no A is B. So no A is B in the sense two different circles, two non-connected circles, right? So A and B will be not connected. So this is the meaning of no A is B. So since if a word called no or not occurs in a statement, no A is B or some A is not B. some B is not A. So no C is A. So these are all called negative statements. So for this negative statements, we can make negative conclusions. So let's say, so this is the Venn diagram for no A is B. Since it's a negative statement, we can derive negative conclusions. So to represent a Venn diagram, so represent two different circles and with a connecting line. With a connecting line. This connecting line indicates there is no direct connection between both of this. So this connecting line represents no connection between both of the circles. So what are the possible conclusions? Like no A is B, no B is A, some A is not B, and some B is not A. So when no comes in statement, some or not should follow in the conclusion. As we told, so some A is not B, some B is not A. So no A is B and no B is A. So this is called negative conclusions, right? So this all A is B and no B is C. So all A is B and no B is C. So let's take this all A is B. So A circle will be within B circle and B is not connected with C, but we need to represent this with a connecting line which indicates no direct connection. Clear? So these are the conclusions. So between A and B, so all A is B, some A is B, and some B is A. So between B and C, so no B is C or no C is B. So some B is not C and some C is not B. So between A and C, so no A is C and some A is not C. Right? So let's go with the 10th concept. So all A is B and no A is C. So all the A values will be within B and no A is C. So this is similar to the previous one, but the connecting line should represent between A and C and not with B and C. Clear? So these are the conclusions. So between A and B, so all A is B and some A is B and some B is A. So between A and C, so no A is C or no C is A. Some A is not C, some C is not A. So between B and C, so between B and C, like some B is not C or some C is not B. So 11th concept. So some A is B and no B is C. So some A is B and no B is C. So B is not connected with C. So these are the conclusions we can make. So between A and B, so some A is B, some B is A. So between A and C, so no B is C or no C is B. Some B is not C or some C is not B. So between A and C, so no A is C or no C is A, and some A is not C and some C is not A. Right, so this is the last concept. So we are dealing with this 12th concept. So some A is B and no A is C. So some B is C and no A is B. Right, so this is A and this is B and this is C. So this are all the conclusions. Yeah. So I hope you got all the 12 concept. So if you have any queries, you have 1 minute of time. So you can just think of, and if you got any queries in between, so you can put it in our comment box. So any queries in between, guys? So I hope it's clear about all this 12 concept. Okay, let me know if you have any queries. So you can use your chat box. Okay, so I think like you don't have any doubts. Okay, so that's fine. So let's move on. So next, just remember this merging concept. So this concept is too easy. So just remember this three rules. So it's enough to solve you problems. So this concept is applicable when more than one conclusion doesn't follows. So just remember these three rules, and whenever you heard a statements or whenever you are going to solve a statement, so just see whether all these rules satisfies for the statement. If all these rules satisfies, then your answer will always be either one is true or second one is true. So either one will be true or the second will be true. So your answer will always be this, either one or two. So you can make a note of this. So this is called merging concept. So let's name this three rules. The two non-following conclusion must be of the same characters, and one conclusion must be positive and one conclusion must be negative. So let's read this again. So the two non-following conclusions must be of the same characters. So one conclusion must be positive and one conclusion must be negative. So positive, as you already know, what is a positive conclusion? So positive means which includes all A is B and all B is A. So some A is B and some B is C. So this all called positive conclusions, and you know about this negative conclusions as well. So when we have no A is B, no B is A, some A is not B, some B is not A. So this all called negative conclusion. So just remember these three rules. The two non-following conclusion must be of the same characters, and one conclusion must be positive, and other must be negative. I'm sorry. Yes. So I know this merging concept is not much clear to you. So let's take some examples and let's go on solving those examples. So it will be clear for you to understand this merging concept. So statements. So all lotus are flowers and no lily is lotus. So all lotus are flowers and no lily is lotus. So they have given the conclusion like no lily is flower and some lily is flower. So how can we represent this in Venn diagram? So all lotus are flowers and no lily is lotus. So lotus will be within flower circles, and lily is not connected with lotus, so it will be a separate circle, and we will represent this two with a connecting line which indicates no direct connection, right? So okay, fine. So let's check. So no lily is a lotus. No, lily is a flower. No, lily is a flower. Yes, it's a true statement. And some lily is flowers. And this is a false statement. So we can say that conclusion one is true. No, we can't say like conclusion one is true. So just check with these two conclusions. So all lily is flowers and some lily is flower. Does these two conclusions are speaking about the same characters? Yes, both the statements are speaking about. I mean, both these conclusions are speaking about the same characters. They are speaking about lily and flowers, right? So they both are speaking about lily and flowers. So the first rule of the merging concept satisfies. So both the statements or the conclusions are speaking about the same characters. So next rule is about one must be a positive conclusion. So yes, one is a positive conclusion. So this some lily is flower is a positive conclusion. So hence second rule satisfies. And we have no lily is flower. So no lily's flower is a negative conclusion. Yes. So all these three rules satisfies. So hence the merging concept satisfies. So the answer will be either one or two. So you can just regret all this conclusion. Don't check whether it is a true or false. So in conclusion, both are speaking about the same characters, and one is positive and one is negative. We can directly go for the answer, and the answer is either one or two. Either one will be true or the second one will be true. It's clear. So any queries in this merging concept? Okay, so let's solve another example. So some cameras are radios and some statues of cameras. So some cameras are radios means this camera and radios are connected circles, and some statues of camera means this statue and cameras are connected circles. So we have some radios or statues and no radio is a statue as a conclusions. So let's check these two conclusions, and both are speaking about the same characters about radios and state statues, right? So one is positive and one is negative. So this what state conclusions follows the merging concept rules. So hence the answer will be either one or two. So statues will be connected with cameras and cameras will be connected with radios. So we can before checking this conclusion whether it is true or false. So let's apply the merging concept and we can directly say it as either one or two as a answer, right? So this is a possibility diagram. So in this syllogism, so just remember the 12 concepts like how to draw a Venn diagram, so how to make a conclusions and all, and remember a merging concept and this possibility table. So if you remember these three concepts, it's enough for you to solve problems. So if you are aware of these three, so you can directly or you can easily score your marks. So whenever a possibility or can comes in the conclusion, we need to check for this table. So just remember, whenever a possibility or can word comes in your conclusion, it's always true. So consider that conclusion as true. So if a word called possibility or can comes in your conclusion, consider that conclusion as true, right? So let's take some examples for this possibility. So some mangoes or apples and some bananas are apples and some branches are bananas. So some mangoes or apples and some bananas are apples and some branches are bananas. So let's draw a Venn diagram for this. Some mangoes or apples and some branches or bananas. Sorry, some bananas are apples and some branches are bananas. So four circles connected with each other. So they are connected correspondingly. So this is a Venn diagram, and let's check for the conclusion. So some mangoes or bananas. Is it some mangoes or bananas? No. No direct connection between this mangoes or bananas, and this conclusion is false. And some branches being apple is a possibility. So some branches being apple is a possibility. There is a word possibility in this conclusion. So as I already told you, whenever a word possibility or can comes in your conclusion, so just take the conclusion as true. So it will be a true statements or the two conclusions. So some branches are mangoes. So some branches are mangoes. No direct connection between branches and mangoes, and this is false. And all apple being mango is a possibility. So all apple being mango is a possibility. So yes, there is a word possibility, and we can take this as a true conclusion. So so the second and the fourth conclusion will be true, right? So this is our answer. So let's check this answer. So yes, So no direct connection. So first conclusion is false. And though there is no direct relation, so there is a word possibility in the conclusion. So second one is true. So third one is false because no direct relation. So four. So but in four there is a word possibility. So we can take it as true. So the conclusion two and four follows. Okay, so this is the next example. So all circles are squares and some squares are roses. So all the circle will be squares and some squares are roses. So let's check conclusion. So all roses being squares a possibility. So there is a word possibility, yes, it's true. So can all roses circles be roses? So there is a word can in our conclusion. So this is also true. So the answer is both 1 and 2 follows. Okay. So is it clear? Okay, I think you don't have any doubts in this. So let's move on with solving exercise problems. Okay, so this is our first exercise problem. So let's check with the statements and you can draw a Venn diagram for this and then you can go for checking conclusions. So statements, so some red or blue and all white or blue and all yellow or red and some white or orange. So these are the statements. So draw a Venn diagram for this and you can check for the conclusion whether there's three conclusions out of this three conclusion which will be true and which will be false, and you can select only only the options which are available here. Let's just solve this and tell me the answer. So if anybody get the answer, just put it in a chat box. So let's verify whether your answer is true or false. Okay, so let's draw one diagram for this. So let's check with the statement one. So conclusion one: some white or yellow. Is it some white or yellow? No direct connection. It's false. So some orange or definitely red. So we can't define it. So we can say like uh, if there is a word possibility, we can say like it will be true, but we can't define it. So whenever a word definitely occurs in your conclusion, so you can check for the conclusion. So don't directly go with the definitely word. So then we have at least. So yes, the third conclusion is true. So only three follows. So here the option will be option B if conclusion, if only conclusion three follows. Okay. So any doubts? Okay. Nihal Puchari. The answer is C. Okay. Nihal, I hope it's clear for you now. Yes. Okay, fine. So let's move on with the second problem. Okay, so some umbrellas are sticks, and some sticks are balls, and some balls are bats, and all bats are guns. So these are the statements, and they have given the conclusion as well. So some balls are umbrellas, and some guns are bats, and some sticks are guns, and some balls are guns. Okay. So now draw a Venn diagram and check which conclusions are true. So based on that, select one options from A to E. So any answers? Okay, so let's check the answer. Okay, so let's draw a Venn diagram first. So this is what the Venn diagram we got. So let's check the conclusion. So some balls are umbrellas. Is it some balls are umbrellas? No direct connection. So it's false. So some guns are bats. Is it some guns are bats? Yes. So second one is true. And some sticks are guns. No direct connections. It's false. And the next is, and some balls are guns. So some balls are guns. Yes, some balls are guns. So only 2 and 4. Uh, so only 2 and 4 follows. So the answer is option B. Only 1 and 3 not follows. Okay, so here 2 and 4 follows, but in options, so we can select like only 1 and 3 not follows. Is it clear? So this is a third one. So some cards are notebooks and some notebooks are dictionaries and some dictionaries are files and all files are employers. So this is your statements, and let's go with the conclusion. So some envelopes are notebooks and some files are notebooks and some cards are dictionaries and no dictionaries and envelope. So just draw a Venn diagram and just check with the conclusion and just tell me the answer. So let's check for the answer. So before that, did anybody got the answer for this? No. Okay. So let's check. So cards, notebooks, dictionaries, files, and envelopes. So some envelopes are notebooks. So no envelope is a notebook, so it's false. So some files are notebooks, and some files are not notebooks, so it's false. So some cards are dictionaries, so no direct connection, it's false. So no dictionary is an envelope. So no dictionary is an envelope. So this is also false. So the answer is option A, which is no, all not follows. So every conclusion is false here. So we can select all not follows. Okay. So this is all about syllogism. So we can now enter into the direction sense problems. So is this syllogism concept clear? So if my voice is audible, please do reply with yes. So is this all syllogism concept is clear? So, okay, fine. So, next topic we are discussing now is about directions. So, hope you have heard about this direction kind of problems. So, the problem will be related to the directions. So, overview. So, let's check the concepts, basic concepts, and let's solve some different types of questions and practice on different types of questions. So fine. So direction is a path in which a person moves to reach a predetermined or a certain destination. And this word is not a new coined word for you. So you already heard about this directions in any of the other ways. So direction is a path in which a person moves to reach a predetermined or a certain destination, right? So mainly we have four main directions, and you also know this. So we name it as a north, south, east, and west, and the angle between two corresponding directions will be always 90 degree. So remember this: the direction between uh, two corresponding angles, the two corresponding directions will be 90 degree. And in adding to this four main directions, we have other four cardinal directions. So we call it as a northeast, northwest, southeast, and southwest. So four main directions and four cardinal directions, so totally we have eight directions. Eight directions. So north, northeast, east, southeast, south, southwest, west, northwest. Clear? So the angle between any two corresponding main direction is 90 degree, and the angle between any two corresponding cardinal directions is 90 degree, and the angle between corresponding cardinal direction and the main direction is 45 degree, right? So and we all know that sun rises in east, right? So sun rises in east. So if we view to the sunrise from east, so our left side will be a north side and our right side will be a south side. So fine. So in 12 noon, so exactly in 12 noon, so this is our north. So upward direction is north and southward direction is south, and the left side is west and the right side is east. Clear? And this is about the shadow table. So during sunrise, if a person is facing towards north, then his shadow falls on his left side. So during sunrise, if a person is facing towards north, his shadow lies on left side. During sunrise, if a person is facing south, his shadow lies in right side. So during sunset, if a person is facing towards north, his shadow lies in right side. And during sunset, if a person is facing south, and his shadow lies in left side. So just vice versa between sunrise and sunset. So during sunrise, so north means it is left and south means it is right. And during sunset, north means it is right and south means it is left. So during 12 noon, exactly at 12 noon, the person may face towards any of the directions, so there will be no shadow. And you will be knowing this, and this is also a not new concept for you. So during 12 noon, your shadow lies exactly to the same line, to the straight line of yours. So we can shadow will not appear as well, right? So the types of questions like distance calculation and facing of the person, and shortest distance using Pythagoras theorem. So you may heard about this Pythagoras theorem in your schooling. Okay, so let's see this. So we have distance calculation and facing of the person types of problems, and we also have shortest distance by using Pythagoras theorem, and we have rotational type of problems and shadow based problems and clock based problems, right? So we have some tips. So initial facing of a person is most important thing. So if the initial facing is not mentioned in a question, so it's not possible as to solve the question. So initial facing of a person, so they will be mentioning like let's say the person is initially facing towards north, or he is facing towards south. So initial facing of the person is most important, and in question if they are not given you the initial facing, it's not possible for us to solve a problem, right? So always try to draw and answer the question to avoid confusion. So always try to draw, so it will be like step by step procedure. So if you draw something, it will be more easier for you to solve the questions. So have a naming for starting and ending point, right? So make sure the lines matches with the given distance. So let's say like the line, so for 2 meters of traveling we may indicate this 2 meters with a line, and also for 5 meters we also represent this with a line. So thing is, this 5 meter line should be larger than this 2 meter line. So this is a common sense, right? So 5 meters line will be larger than 2 meters of line. So you don't need to write 2 meters, exactly 2 meters line and exactly 5 meters line. So we can represent this two lines. So one is 5 meters and one is 2 meters, right? So please read the tips again. So after this, we can go on solving the problems. Okay, so let's solve problems related to this. Okay, so type 1 is about distance calculation. So this is a given question. So a person facing south goes 2 meters in the same direction, then turns to his right and walks 3 kilometers, again turn to the left and he walks 5 kilometers, and finally he walks backwards towards north for 7 kilometers. So what is the distance he has to travel to reach the starting point, and when which direction? So I'll just repeat this question again. So a person facing south goes 2 kilometers in the same direction, then turns to his right and walks 3 kilometers, and again turning to the left, he walks 5 kilometers, and finally he walks back towards north for 7 kilometers. So, what is the distance he has to travel to reach the starting point, and in which direction? So, please remember this direction. So we have four main directions and we have other four cardinal directions. So along with all this, we call it as eight directions. So they are saying like facing a person facing south. A person facing south means the person is facing towards this side, goes 2 kilometers. So a person facing south goes for 2 kilometers. So this is the starting point. Yes, so this is the starting point, and he goes for 2 kilometers in south direction. So then he turns to his right and walks for 3 kilometers. If a person is facing towards south, so this is the right side and this is the left side. So he is taking right. So he takes right and go for 3 kilometers, and again turning to left, he walks for 5 kilometers. So if person is facing towards this direction means this is west. So this direction is west. So west means so this is the right side and this is the left side. So here he is taking left and walking for 5 kilometers. So finally he walks backwards to north for 7 kilometers. So he is facing towards south and he need to go back to the north for 7 kilometers. So he is here and he go back for 7 kilometers. So, what is the distance he has to travel to reach the starting point and in which direction? So, the person is presently in this position and the starting point is here, and we need to calculate what is the distance between this to this. So, obviously, so if this is 3 kilometer and this should be a 3 kilometers, right? So, I need to move in this direction, and this direction is called east. So, the answer is 3 kilometer east. So, is it clear? So if you have any queries with this problem, you can directly ask in the comment box. Okay. So I think no queries with this problem and it's clear for you. Is this slide visible now? So can anyone just reply if this slide visible? So Nihal Pujari, can anybody to reply if my voice is audible and the slide is visible? Yes. Okay, fine. So let's move to the next slide. Okay. So this is the second problem. Okay, a person starts walking towards east. So after walking 30 meters, he turns left and walks for 10 meters straight. So again he turns left and walks for 45 meters, and again turning to his left, he walks for 10 meters. So how far is he from his starting point? Okay, so a person is facing towards east. A person is facing towards east. So east is this side. A person is facing towards east, and he walks for 30 meters, facing towards, I'm sorry, facing towards east. So facing towards east, he walks for 30 meters, and again he turns left. He turns left. So if you are facing towards east means, so this is the right side and this is the left side, right? So then he turns left and walks for 10 meters, and again he turns left and walks for 45 meters. So if you are facing north, so this is the right side and this is the left side. So he takes left and walks for 45 meters, and he walks for 45 meters, and again turning to his left and he walks for 10 meters, and again turning to the left he walks for 10 meters. So this is the total distance. So this is the total distance. So now what they are asking is how far is he from the starting point and on which direction. So this is 30. So this is total 30, and this is total 30, and this is total 30, and this is total of 45. So 30 minus 45 is 15. So I need to walk for 15 meters to reach his starting point, and along with which direction. So this is the direction, and this direction is called east, right? So I hope it's clear. So this is the second one, third one. So Ganesh, starting from his house, walks 10 meters towards north, and then turning to the left. So after walking for 6 kilometers, he turns to the right and walks for 8 kilometers, and then he goes back for 20 kilometers right. So now, in which direction is he from his house? So this direction sense questions may looks difficult, but when you go on solving by steps to step, it will be more easier for you to solve. So initially, so it will be facing towards north and walks for 10 kilometers towards north, and then turns to his left. So if you're facing towards north, so this is the left side and this is the right side. This is the right side. So he's taking left and he walks for 6 kilometers, and then he turns for right and walks for 8 kilometers, and then he go back 20 kilometers straight. So then he go back for 20 kilometers straight means, so this is already 8, and then he will go back for 12 kilometers. So 8 plus 12 is 20. So totally he go back for 20 kilometers. So now, in which direction is he from his house? So in which direction is he from his house? So this is the direction. This is the direction, and this direction is called northeast. This direction is called northeast, northwest. I'm sorry, and this direction is called northeast, and they are asking like in which direction is he from his starting point, so that we need to view through the starting point. So this is the starting point. So if you view through the starting point, this is the direction, and this direction is called southwest, and the answer is southwest here. Clear? And this is the type 2 shortest distance calculation using Pythagoras theorem. So you know about this Pythagoras theorem. So here, if we take this as a triangle, and if I name this as A and this is B and this as C. So A, B, C means, so and we call this side as a Pythagoras theorem. I mean this side as a hypotenuse. hypothesis, like hypotenuse. So this AC is a hypotenuse. So if we want to calculate this, we can just say this as AC square is equal to this AC square will be equal to BC square and AB square, BC square and AB square. So if we take this root to the other side, then we can say that AC, or the hypotenuse is equal to AC square plus, BC square plus uh, BC square plus uh, AB square. So AC is equal to root of AB square plus BC square. So or we can also say that X is equal to root of A square plus B square. So first, let's see this question. So Roshan walks for 20 meters south. So this is the initial stage, and if he walks for 20 kilometers south, and he turns to the right and walks for 40 meters. So he turns to the right and he walks for 40 meters, and then he turns to the right and walks for 10 meters. And again, he turns to the right and walks for 10 meters, and finally he turns to the left and walks for 5 meters, and finally he turns to the left and walks for 5 meters. So in which direction and how many meters away from his standing from his starting points? So we can't directly solve this, so we need to use Pythagoras theorem, so that we can assume a dotted line here. So we can assume a dotted line here. So and we can name this as AB and X. So the formula is X is equal to root of A square plus B square. So X is equal to root of what is the A value? So A value, so this is 20 meters and this is 10 meters, and we can minus this 10 out of 20, so the remaining is 10. So A square is 10 square, and we have 40, and we have 40 meters here, and this is 40 and this is plus 5. So the total B length is 45 meters. So this B is 45. So root of 10 square plus 45 square is root of 2125. 2125, root of 2125 is similar or approximate to this 46 meter. Is it clear? Yes. So again, let's solve this. Van running 25 kilometers north from the shed takes rights and travel for 30 kilometers. Then takes left and travels for 15 kilometers to reach his van. So how far is the van from the starting point? So let's read this question again. So van running 25 kilometers north from the shed takes rights and travels for 30 kilometers, and then takes left and travels 15 kilometers to reach his van. So how far is the van from the starting point? Clear? So this is the starting point of the van. So this van is facing towards north and travels for 25 kilometers. Yes, and again taking right, this travels for 30 kilometers, and then takes left and travels for 15 kilometers. So this is the starting point, and this is the present situation of the van. So we need to calculate the van and the starting point distance, right? So let's represent this in a dotted line, so we can connect a triangle. So name this as X, A and B. So A value is this is of total 30, right? And this is of total 30. So 30 will be our B value, and we have 25. This is 25 and that is 15. So 25 plus 15 is how much? 40. So we have X is equal to root of 40 square plus 30 square, which is root of 2500. So 2500, root of 2500, which is equal to 50 kilometers. So I hope it's clear. So this is the next question. So Mary started from her house and walks for 13 meters north. So then turned right and walks for 10 meters. So she then took a right and walks for 5 meters, and then she turned left and walks for 5 meters. So how far is she standing from her house, right? So this is the starting point, and she is traveling towards north for 8 kilometers, and then uh, she is taking right side and walking for 10 meters, and again she is taking right and walking for 5 meters, and again she is taking left and walking for 5 meters, and she is presently here now. And what they are asking is, so how far is she from her house, how far is she from her house. So we can make a dotted line to represent this and this line, so that we can make a triangle. So what is the a value and what is the b value? So this is totally of 10 and this is totally of 5. So 10 plus 5 is 15, so a value is 15, and this is totally of 13, and this is totally of 13, and this is totally of 5. So 13 minus 5 is 8, so this is 8. So a value is 15 and b value is 8. So root of 289, which will be equal to 70, right? So do you have any doubts with this? Any doubts with this? So that's fine. So let's move on with the next concept. Okay, so this is a type 3. This is about rotation, clockwise and anti-clockwise. So if we go for rotation, we know this, we have clockwise and anti-clockwise. So let's check this. So you are facing southwest and you turn 90 degree in anti-clockwise and 180 degree in clockwise, and again 90 degree in the same direction. So which direction are you facing now? So if it is clockwise, so just consider the clockwise as plus, and if it is anti-clockwise, and consider this anti-clockwise as negative, right? So 90 degree anti-clockwise, so minus 90, and 180 degree clockwise, so plus 180 degree, and plus 90 degree in the same direction, which is clockwise. So we have minus 90 plus 180 and plus 90. So 90 get cancelled, which will be equal to 180 degree clockwise. So hence 180 degree clockwise from south to west. So from south to west, 180 degree clockwise. So means which is northeast. This is northeast. So just consider this clockwise as positive and this anti-clockwise as negative. Clear? So and this is a type 4, which is about shadow based problem. So after sunrise, Rekha, while walking on the road, she met Prema, and Prema's shadow falls exactly to Rekha's right side, and they are facing each other with direction of, which is the direction of Prema facing. Okay, so they are asking about the Prema's direction of facing, right? So for this is a shadow based problem, so we need to remember those shadow table. So during sunrise, if a person is facing towards north, then his shadow lies in left side. So if he's facing south, then his shadow lies in right side. So during sunset, if north means it is right, if south means it is left, and in 12 noon, if we are facing any direction, his shadow never appears, because it will be always in a straight line to the man, right? So at the sunrise, after sunrise, Rekha, while walking on the road, she met Prema. So Prema is opposite to that of Rekha. So there will be no opposite. So Prema's shadow falls exactly to Rekha's right side. So if you are facing, if Rekha is opposite of Prema, and Prema's shadow lies in exactly to the right side. So during sunrise, so it's facing towards, and Prema's shadow is facing towards Rekha's right. It's Rekha's right means that is south, right? And she is Rekha is just opposite of Prema. So for Prema, it is left side. For Prima, if Rekha and Prima is facing each other, means they are in opposite of each other. So if Prima's shadow lies right to that of Rika, then Prema shadow lies left to that of Prema, right? So the answer is not here. Okay, so I hope it's clear. So how to solve this direction facing, what is distance calculation, and shortest distance calculation, and clock based and shadow based. So these are the four types. So if you go on solving these four types of problems, so you can directly or you can easily solve many problems that are related to the directions, and you can easily score in your aptitude exams. So is it clear? Okay, so is it clear? So we can wind up for the session. So please stand solving problems. So it will be easy for you to score, at least score something in your TCS, right? And if you are thorough with the concept and you can easily solve, and I hope everybody who are watching this, you all the best. I wish you all the best and happy Yugadi. Okay. So well, thank you guys. So we can wind up for the session now. And again, all the best for your future. So I hope you get your dream job.